Okay. So this talks about a lot. I mean, what sort of a file is being considered, streaming data, community hardware. You can just read through it. There is nothing big deal that has been explained. Let's go in a little bit more detail into what is happening. So I want to bring that the picture which we have made yesterday or in our last session. Where exactly is that? That is not the one. Data storing, is it? Yeah, this is the one. Okay, so first session, do you guys remember? Employee.txt, we have chopped it down to 4 equal parts or 3 equal parts and 1 was the remaining stuff. Now we're going to drill down a little bit more into it. And when I drill down more into it, what exactly I'm doing is I'm going to make a copy of this block. I'm going to copy of another this block, this 3 blocks. I'm going to make a copy of it. So okay. So what I'll do is I'll use a paintbrush again. Try to bring in, copy that figure over there. Take this picture completely. Control C and Control V. Done. Okay, that's done. And let's close the other one. Let's close this one now. Okay. So now what exactly we are trying to do is I have A, B, C, and D. Okay. First process, apart from splitting this into different block size, one other additional stuff that is going to do is, which we are going to see today, is creating a copy which is known as a replication factor. Let me use the same thing. So what is happening? I have a copy of A. I have a copy of B. I mean, it's exactly the same size. Okay, I mean, I can't fit in the same size. So, but you understand that, yeah. So I have a copy of C and I have a copy of D now. Okay, so this is the first task that has been done by our Hadoop system. What is it called? RF, which is nothing but replication factor. Okay, let me name it as replication factor. Okay. So this replication factor is, and 90% of the stuff what I'm talking about is a parameterized one. Okay, you can change based on your convenience and based on your need. So if I say my system or this particular file of mine is very, very crucial for me, I can maintain a 10 replication factor. So I have a parameter file or a configuration file available with me where I need to say how many number of copies I need to maintain for each file. I can just go and mention over there 5. So the moment I mention file, what will happen is 5 different copies will get maintained. So for this one, we'll have 1, 2, 3, 4, 5. 5 different copies. At one time, I'll have 5 different copies. That's what exactly it means, including this stuff. Okay. So that's what it means. So right now, how many replication factor I have now? With this diagram, considering this diagram? No. So that's exactly the reason I asked this question.
1.
Not really. Replication factor. So that okay. Exactly. So that's going to be 2. So at a given instance of point of time, how many number of copies are being maintained is what? So it's not 4. Why exactly it's not 4? Because what we're seeing over here is not a copy. 4 different copy we maintain, right? So I have just 1 copy of this A available. So basically what is happening, this emp.txt file is first chopped down into 4 equal parts. Okay, I might be saying equal because I don't want to bring in my language power or anything over here. Okay, so understand that when I say equal parts, it's this 8 also is considered over there. So 4 equal parts, right? But these are different contents of my file, right? I hope everyone understand that. So this is a different content, this is a different content, and all this file. So one big file cut down into 4 equal parts, right? And then each of those equal part, I'm making a copy of it. So this copy is this one. So this copy is this one. This copy is this one. This copy. So at a given instance of time, there is only 2 copy we maintain, right? So this is 1 copy and this is another. I mean, this is actual file and this is a copy of it. So at a given instance, I have only 2 copies of it. And that's exactly what replication factor stands for. So hope that's clear. That's fine. All right. So that's the first thing you need to understand. And now we are going to drill down a little bit more in detail now. So initially what we said, I had a file A stored over here, then B went over here, C went over here, and D went over here, right? So now my task is, let's name it as, where is this guy? Okay. Let's name this guy as pink in color, is it? All right. So this is A1 maybe, right? A1. And this guy is B1. This guy is C1. And this guy is D1. Right? So everyone understood what exactly is happening. So now, next task is, so I have A maintained in this particular computer, right? A copy of A is being established over here, or I have placed an A over here. So next, logically, where exactly the A1 should be? Logically speaking, it should not be residing in this particular location, right? In that case, it doesn't make sense. I have a copy of it, exact same copy, maintaining the same computer doesn't make any sense, right? So I'm going to maintain an A1 over here, right? Now I have a B1 place. So already I have a B. So maybe I'll place the B1 over here. And this logic is completely taken up by the rack awareness algorithm, or it places based on algorithm present in the node. So this, based on that, is what is getting placed. Okay, so that easy access, maximum redundancy, and also fault tolerant scenario. That's exactly what is being covered over here. So C I already have over here. So I'm going to store C1 over here. And D I don't have over here, so I'm going to store D1 over here. So you may have a question now, why C1 is stored over here, why not over here? It can happen. So based on, there is a certain algorithm that's running inside the system, which determines which particular block of file should go and reside it. And there is nothing hard and fast rule that this should not be sitting over here. It completely depends on how the computer wanted. And you do not have control on where exactly the C1 needs to go and sit in. That's all the key thumb rule is. A user or a client doesn't have a control of where exactly my replication copy wanted, and that's completely governed by the Hadoop system. Is that point clear? Any doubt or any questions on this? This is the basic foundation layer for understanding the Hadoop. And why exactly we maintain all those things? Typically a fault tolerant scenario. And how exactly is that? Think of a scenario where this particular node is going to get failed. No, great. Okay, Kaushik. Please do respond for your steps so that, I do understand, yeah, you guys are able to figure out what I'm trying to say, because that's one of the challenge conducting the session in a remote place without having an eye contact. So think of a scenario, this node is failed, okay? It's a failure of this particular node. What should happen then? Questions for you guys. This particular extreme 3 is failed. When I say failed, it's crashed. There is no data, nothing is available. So now, what is the challenge over here? So now, what are the data block sitting inside that particular node? And how do you think this situation can be handled? Yeah, great. So C and D is the correct. So C and D1 is the particular block which has been completely failed. So now, how exactly I'll be able to recover the data? Is that first question is, can I recover the data from the existing scenario, what we have explained now? Yes, right. So this is possible because I have for C, there is a replica that is available on a C1, correct? And for D1, I have something sitting over in this block. So I do have a proper, complete situation of a replica being maintained. So now the task that the master will do is, what has happened? Because of this failure, our replication factor for 2 blocks, that is C and D1, or C and D, has reduced by 1, right? So I have only 1 copy of this maintained at this point of time because of this failure. I got it? Is that, you guys agree to that point? When this computer fails, I have only 1 copy of C and D1 maintained. Is that correct? C and D maintained. Everyone agrees to that point?
Yes.
Yeah. All right.
Correct.
So now the thumb rule that the Hadoop go ahead with is, at any point of time, I need to have whatever is the defined replication factor, I need to maintain it. So the moment that the failure happens, so Hadoop understand that, okay, there is a low level of replication factor for two blocks, that is C and D. So what exactly it's going to do is, this C1, it understands that it's already an existing C1 over here. Okay. So it will take a copy of this C1, okay, and make a copy over here. Why is it not coming? Let's put toothbrush and then put it over here. And that's a C over there. And now the next one, what is happening? This D was missing, correct? So that D, it finds out where exactly the D is available. One D is found over here. So take a copy of D and place it over here. And that's how it maintains. Automatic failover recovery is being maintained by this. Now I'm expecting some of the questions from you guys. Yeah. Yeah.
So that means RF to be maintained for each and every data chunk, whatever is inside the nodes. If any of the node fails, it has to, whatever the data is lost, we have to maintain the RF for that.
RF is a replication factor, right? I mean, hope you got that. That's correct. So at any particular moment of time, given point of time, need to have whatever is been defined. So basically my defined replication factor for this ecosystem now is 2. What does that mean? At any point of time, my block size should be 2. I should have, for each block, I should have 2. So in case if it's not there, somewhere in the log it's going to tell minimal low replication factor is being maintained. So make sure you're trying to copy it from somewhere, whichever is the file having a low replication factor. Make sure you are maintaining exactly the same replication factor. That message will keep on going for this master, and that will be forced to do that copy and paste stuff. Okay, so now
one doubt is there.
Yeah.
When we were talking about name node and secondary name node, okay.
Yeah.
So you said that the edit log, it will be it will merge with the FS image in the secondary name node, and that secondary name node will replace the existing FS image in the name node, right?
That's correct.
And that FS image which was earlier in the name node, that will be taken as a backup.
That's correct.
And that backup will be stored in name node or secondary name node?
No, this backup will be present in both this name node. Here also there will be a backup, here also. So basically what is going to happen is, there will be a huge backlog of file with sitting in this particular place. So maybe in an hour time, or maybe in 24 hours, maybe 24 backups will be present. So in case if you're talking about a system which is existing for 365 days, you may see maybe 3,000 files will be sitting over here. So there is a manual cleaning done by administrator. So that is one of the tasks of the administrator. You'll say whichever the files, because I do not want to maintain a backlog of a system which is existing in 1 year back, or maybe 1 month back also. I don't need it, right? So this FS image is maintained only in case of this kind of scenario. This kind of scenario. Okay, I mean, that was a question I was about to ask. You made me answer that question now anyways. So basically what is happening is, so where do I get this information?
From the backup.
Right? No. So where do I see, when a failure happens, I need to understand what, because there is no heartbeat signal going, I understand that this particular node has failure. Everyone agrees to that point, right? Plus, what are the files sitting inside, or what are the blocks sitting inside my DN3? How do I get this information? I was expecting that question from you guys. Okay, so how do we get that information? In fact, I have answered half of it. So now I think, yeah, so basically, exactly. So that's the metadata or the FS image or edit log. Every of this will contain those information. And that will tell you, okay, data node 3 was having C and D. Make sure you're going to do a replication over here. That's exactly the answer for it. Yeah, you guys are right.
Okay, sir, but the backup FS image is stored in both SNN and NN.
Correct. I'll have both places this backup image in both the places. And this typically depends on how exactly the administrator want to do it. So he may say, okay, I just maintain only 5 backup over here, and whenever the remaining 5 comes in, delete the rest of the. I want at a given point of time, I just want to have it 5. So it clearly is defined by an administrator who is maintaining your show. So he has every right of playing around with this file. But here, minimum a backup of a month file will be kept, just because of the reason. Whoever is in the administrative level might be knowing it. So any point of a time, you say some new resource comes into your system and he goofs up something, okay, and we'll be forced to go back. Maybe today, what is the date? 19th of Jan, right? 19th of Jan. So today you realize that there is a big goof up that has happened in your system, and you need to go back to 10th of Jan situation, because on 10th, every of my system was correct. Post 10th, all my data is incorrect. So that scenario, to overcome that, we do have maintained many of those backups, and when we go back to that particular state. So that's why maybe 1 or 2 months. It depends on truly on your shop or truly on your installations. At times you maintain it for 6 months, at times maybe 1 year. Very, very less application make it for 1 year, because if you're going to go back and restore a system 1 year back, I don't think that system is worth enough for doing any sort of research. So maximum one month, that's a logical trait I believe we would go for.
Okay, sir. Thank
Okay.
you.
Hi, this is Swapna here. I have just following question to that.
Okay.
So whenever we start name node, does it go and talk to secondary name node and get the FS image? Like, I just wanted to understand, as soon as we start a name node, what is the background picture it happens?
All right. No, it does not directly speak to the secondary name node. So what exactly is going to happen is, the moment I start my name node, first and the simple task, what it's going to do is, it's going to take up this FS image from my let me put you guys on mute. I can that. If you look back, mute all and continue. All right. Yeah. So basically what's going to happen is, so if you have an FS image, it's been stored in the hard drive. So drive FS image will be brought in the memory. That's exactly what has been done when you start the name node. That's exactly what has been done in the starter. And one other edit log, an empty edit log will be created. Apart from that task, an empty edit log will be created for a new log. Whatever is being pushed by the name data node needs to be accumulated over here. That's all the task that's going to happen in the first start of the name node. And when exactly secondary name node comes into place is there is a defined interval kept for that also. Maybe 30 seconds or 30 minutes. In 30 minutes of time, what needs to be done? Copy this FS image, copy this edit log, merge it, bring it back over here, and then start doing the processing. And why exactly this system is not doing that is, name node should not be burdened with any of the additional processing. And that's exactly the reason for bringing this guy in. Because anytime any client or any user going to interact or need to store the data from, that's direct. This guy is the one which is made to take up that load. Any information the client require directly comes and hit to this system. So this system should be always free for taking the client request. So that's why every other burdening process is being taken up by the rest of the guy.
So like what FS image is file system image, if I'm not wrong, I'm asking.
That's correct. Yes, file system image is what FS image is what I think so.
What are edit log we are getting? Why is it necessary to merge it with FS image rather than we can have a separate file which is containing only edit log?
No, so the reason behind that is, so in case if I don't do that, okay. So basically when I restart that is actually an answer for the continuation which Swapna has asked. So if I don't merging process, okay, if I want to restart my machine, this particular name node, the first step what it's going to do is, it's going to merge this two guy, okay? And think of a real-time scenario, how frequently you're going to do a name node restart. So it will be restart maybe hardly 1 month maintenance time, or maybe it can happen even 6 months maintenance time is the only time you restart your machine. So what would have happened is your edit log would have grown in such a huge pace, so that it may take 4 to 5 hours for your name node to come up if you don't do this process. If you don't do a frequent 30 minutes merge process. So that's the reason for doing that.
Okay, sir. Thank you.
And the interval between the name node and secondary name node is decided by the user,
Yes.
or is okay?
No, it's not by the user. User don't have any control on it. It's all purely by the administrator. Administrator defines how exactly a name node and secondary name node communication should happen. Yes, secondary name node communicates only with the name node. That's correct, Manoj. So anytime a name node fails. So we have spoken about the scenario where the data node dies. Here, when a name node dies, that's exactly the prime importance of secondary name node comes into play. What it does is, one key point, one more additional key point. Secondary name node in no scenario, no case can act as a name node. Okay, this is just a secondary name node. It cannot act as a name node. So in case if this fails, I cannot plug in my wire and take this wire and put it over here and make him as a name node. No, that's not possible. So in case of this fails, I need to bring in a new name node, a new computer, then bring in all the characteristics, change the IP and all those things to match this guy, and then copy this content from here to the name node and then make him act like a name node. That's all the possibility. What is the need for the merge? No doubt if it will take time to merge, that's why we are making schedule merging by secondary name node. But what if we can't make ourselves happy without merging the log with FS image? So that's exactly the reason, right? So I'm talking about the same thing. So if I don't do it, so when you want to bring in the name node, it's going to take you 4 hours for your server to bring up. So think of a scenario. Once you do a restart of your machine, so you're thinking in terms of an administrative point of view. Think of a user perspective. Think of a scenario where you have your Facebook page, you're trying to log in, and for 4 hours, you're not able to post your picture or your selfie into the Facebook. You may find out, is there an alternative social networking site available for you, right? So that's the key importance of it. So you cannot afford to have a business having a downtime of 4 to 5 hours or anything of that sort. So that's a key reason for doing this process in between.
Shaji, I have a question here.
Yeah, go ahead.
So coming to this merging part, so is there really something inside the FS image which is going to change something after some time? Because edit log is changing every of time. But
Correct.
if nothing is changing in FS, then we can do something automatic in edit log, just standalone. Or talk for a month or something.
Your voice is speaking a lot. So you're telling, so why do is it compulsory to merge? Is that your question?
No, my question is, without going for any merging, we can do some automatic purging of the data inside edit log.
See, there are n number of scenario with which, n number of way you can handle it, but for sure, I would definitely think, the one who has architected it would have think every loophole, every scenario with which, but you never know. Maybe you have handled some sort of an architecture or scenario which would have been a better solution. So since it's an open source, n number of guys coming up with this, there would have been a better approach also than this. Yeah.
So exactly my question is, if some automatic purging can be done on edit log, is some stuff inside the FS image which is going to change, or it is same throughout?
It's going to be the same. But when I say same, what's going to happen? This content is going to go and attach to it. That's all the difference. This content is going to be exactly the same. Yeah.
Okay.
Yeah, actually what happened, what I understand, it is a MR 1.0, but we have the replication factor in data node, but there is no replication factor in the master node. So in 1.0, we are maintaining the backup. The backup is a secondary name node. but every 1 hour, every 60 minutes, generally the administrator will set up a automation process. Automatically FS image and edit log will copy from master node to secondary node, name node. But if anything goes wrong in master node in primary level, then administrator will take the backup of secondary name node and restore the primary name node. That is the mechanism is going in 1.0 as per my understanding.
That's correct. That's correct. That's correct. But you have brought in an unwanted component over the replication factor. There is nothing to do with replication factor over here, but the remaining stuff what I spoke about is correct.
Okay.
That's correct. Yeah. So let's move on. I think we may have to get into the next thing. I mean, next place where MapReduce program. So I just don't want to bring in a lot of stuff over there right now. Input split also, I just want to park it aside time being. So when we do actual processing is what we're going to see about input. So this is exactly what we spoke about with our diagram, block A, block B, and block C, how exactly that's getting stored. And data replication, it's known as replication factor. Nowhere it's replication factor mentioned over here. So this data replication is what we're talking about, RF or replication factor. Okay, and this is exactly what we spoke about. So this we have covered already. And this is place where we are talking about splitting our files to 64 MB, right? So that's where 64 MB, it can be 128 MB, 256 MB, and this is exactly the how the file looks like. So we're going to see all those things practically. So we have an XML file available. I mean, hope you guys know how exactly the XML file looks like. So here is exactly how the file looks like, and this is the place where you're going to change it. I can make it as it's provided in byte value or KB value. So this is how exactly it's been set. The value will be sitting like this. dfs.log.size is the property name, and this is the property size. Okay, so this is going to be, I think, 134 MB now, right? So that's how exactly. So we are going to see all these files, property files. So don't get confused on any of this stuff. So key stuff what we need to know is there are 3 configuration files which are key stuff for us. So let me name that so that is there imprint in your mind. So key 3 configuration files that we need to know about is HDFS site.xml. Okay, MapRed. I think MapRed is together. MapRed site.xml. And next one is core site.xml. Okay, so what you need to understand is when I say HDFS site.xml, so any properties that is related to storing of a file, okay, so it's going to be write or storing. Okay, so any property related to storing or writing a data into the file will be stored in the HDFS site.xml. So this, what are we seeing over here? Where is that? Yeah, so this property, can anyone tell what exactly this property should be? This is a read property or write property? This particular option is for read property or a write property. Great. I mean, was that a shooting in the dark or? All right, that's actually a write property. Correct. So I hope you guys are able to understand when I say read and write processing, right? So write, because it's a block size which you're defining, right? So when I'm going to store my data with this particular, what is it, 128 MB or something is what I'm going to store it. So that's correct. It's a write property, right? So whenever a write property comes in, so that write feature comes in, that property needs to be stored in HDFS site.xml, okay? And whenever a read stuff going to happen, this is when a read or processing, okay? Processing, right? And then whichever is common stuff is going to get stored. I would appreciate if you guys could mute in case we're not talking. I can hear a lot of background noise. So continue. Yeah, I made you guys all mute. Okay. So core site.xml is when it's a read or write process. Okay. So it's common process. The property is going to be in core site.xml. All right. So I would like to show you guys some of this before we wind up for today, so that you understand some of this part. Not the XML files, but at least such is the environment so that it's easy for you to know how exactly things work. Okay, so this is covered. Let's take a scenario. Okay, now we have a large file, and each file is represented by one record. Processing constraints and HDFS block. Let's take a scenario. We have a large file and one line of each file represented. And this is exactly the scenario which we're going to talk about, which is nothing but, you guys remember the scenario which we spoke about regarding, I think we have, yeah, this scenario, right? This scenario. So what we spoke about is this particular, this is going to be my A node, not A node, A block. And the session, this part is being picked up by the next guy, right? And I guess someone has asked the question how exactly I'm going to handle that. So that's what we're going to learn now. Let me make this, it's a C block. And let's name the last guy as, oh yeah, I thought the D block. That's correct. Let me get into that. Okay. So the solution for this is what? So what has happened is some of this part is being spanned across the next block, right? So when I do a processing, what I need to do when I do a processing, I should have all these components together so that I can do a processing. Otherwise, it may give me a erroneous result, right? So that is where an input split is going to come as a savior for us. So input split is nothing but it's a logical split of the block size. So in case if some records got spanned to the next block, what it's going to do is it will find out the logical into that particular line. It's going to bring in that particular line to the first block. And then whenever processing is going to happen, that A will process this complete stuff will be processed by A. So that's exactly what has been done by the input split. It's called input split. So that's what has been explained over here. If each map of all the records spanning across the block boundaries be processed. Okay, so the solution for that is input split. I would want you guys to refer this stuff a little bit more. So this is exactly what. So you can read through this. I mean, I don't want to read through each and every of this. So that's exactly what has been explained. In case there is a last record when the block is incomplete. So that's typically what we saw. Well, I'm assuming you guys understood what exactly is that. So reading stuff, I would want you guys to do that. And this is diagrammatically, it's been shown how exactly that's been done. Let's move to this part. How exactly the file write is going to happen. So this, what we have seen with our diagram is the replication happening and how exactly in a theoretical way, how exactly. And this is how the real system behaves. So when we said, let me show you that diagram once again so that we all are on the same page. Okay. So we spoke about this particular replication. Remember, A1 is being stored and how exactly it's getting stored. And now we're going to see how exactly the storage is going to happen. Okay. So this guy, what is going to happen is when a name node is given instruction, where exactly it can be stored, name node given instruction, okay, go ahead and store over here. Okay. What it did is took this A and copied it to this particular DN1. And then what it did is along with the DN1, along with this particular A, this might be a little tricky situation. So make sure you are having a full attention over here. So this, along with this A, what it passed information is, it passed an information of the DN2 as well, telling that once you're done with this completion of A, or a logical completion of A, make sure you're maintaining a copy, exactly the same copy into the DN2. Okay, and that information was sent by the name node. So along with the data, which is being picked up from here, it will have one more small component along with that, which is nothing but the address of the DN2. Okay, and with that address, it's going to copy this A to the A1 over here. And that holds good for every other. So B, B1, exactly the same thing is going to happen. B, and then it's getting copied over here. C, it's taken and copied over here. All this information is, that's how the entire information is getting copied. So that's what is being in detail explained over here. Okay. So how exactly the scenario happens? So FS output stream is the API that has been used for getting this copy done to the system. Okay. First, create the files. I mean, this is very, very self-explanatory. So what you need to understand, what you need to understand is when this copy happens, once this copy to the next node. So basically here replication factor is, will someone be able to explain what is the replication factor? Not that easy, but still want to take who can get this. In looking at this diagram, can anyone tell what exactly is the replication factor maintained over here? Not bad. Yeah, that's right. Is that mentioned somewhere over here? Are you guys trying to fool me? No, right? No. Great. No, replication factor is 3. Nakash is right. So basically why? Because it's storing over here, right? And then that copy is maintained over here. Again, the copy is maintained over here. And then the acknowledgement, once everything is done, is what the acknowledgement is been sent. So once this process is completed, here it's been sent, back to here it's been sent, and then it's been sent back to the name node or sent back to the client, in fact. That's how the replication, I mean, that's how the acknowledgement is been sent. So just go through this once. 2 copies plus original. But when we speak about replication factor, it's always the entire file copy which you talk about. So this might be a key thing when you're going to write your certification. So you need to understand that it's not 2 copies plus original is not the thing. It's replication factor is 3. The original plus 2, but we call it as 3. At a given point of time, the copy is 3. So even though we don't segregate this 1 original and 2 copy, no, it's altogether 3. That's it. Yes, it's not complete MAC to your question. Does replication happens in a sequential manner? It's not complete sequential. It does not wait for the complete complete copy of this thing. And I believe initially when it started, it was complete sequential process. But the latest development has made it not to become a latest. Is what because I see a contradicting blog or information given by Apache and Apache and many other blog sites. So what I assume is in the initial time, first it was sequential, and once it's completed, it's going to go and sit over here. But now it doesn't wait for the completion. Before that itself, once the logical completion is over, immediately it will start making a copy over here. So it's a semi-sequential is what I would say. It's not a complete sequential, but it will make a logical end to this particular copy, and then that whatever is being copied will be pushed to the next environment. That's how exactly it's happening. Whereas there is one more thing which I want to see. Whereas this process is parallel process. A, B, C, D, all those things happens one shot. That you need to understand. This is a parallel, but whereas this copy to this is a sequential process. Whereas all this A, B, C, and D get initiated in parallel. So that's why the power of computation, parallel computing comes in play. Okay. All right. So now, okay, Preetham had a question. So in the scenario where we lose the data, what if we get back to the lost state? Oh, sorry. I think you asked this question. Will it lead to redundancy? No. At any given point of time, we'll not have more data than what is being required. So basically what will happen is if it's come back to the state, administrator can take a call of either removing the entire data from this particular stuff, or by default he can set system that all this administrator have got a privilege for this. Okay, so either what he can make is whenever maybe a stipulated point of time, what he can do is any data comes back, he can say if the C1, which one? The D and C came back over here, right? So D and C, make sure you're going to delete the D and C and let this come back. Or the administrator can even say when it comes back, make sure it's coming back as an empty one. Whatever is been already replicated is replicated. So now this will be treated as an empty one. And then there is something known as a load balancing process, because it see that this is empty and this has 2 files, so it will intelligently do a load balancing process. But never a redundancy process will happen. So anytime a replication factor is being done, that'll be made as so what will happen is, in case if it's come back, the system will start beeping, stating, beeping in sense somewhere the log will be maintained telling that it is over redundant, under replicated, under replicated and over replicated. So it's going to show as it's over replicated, and it'll give a message either to administrator, or it will itself heal by removing one. Or if it's under replicated, it's going to show a message to the system stating that, okay, there is an under replication, you need to make a copy of it. So that's how the system maintains it. Let's always take care of the balancing part of it. I see a question from Sathi. When you said about A and an A1, you said DN1 should know about where A1 will be stored, and hence sames will be copied. But in case of more than 5 or 6 nodes, how will DN1 knows where A1 will be stored? Yeah, so where exactly it's stored, that is purely on the algorithm that's written inside the rack awareness algorithm that is present inside the name node. So we don't have any control. It randomly picks up based on the distance and based on a maximum fault tolerance scenario and maximum redundancy and all those scenario. There is algorithm written based on which the placing of the node happens. So that how exactly it's placed does not depends on how many number of nodes. So in case if you have 10 nodes, there is actually an algorithm in place which makes sure that it's been done. So if you have 2 nodes, it itself does kind of a healing mechanism. So that's their inbuilt algorithm that's available, Kaushik. So that does not affect. So no name node. Sorry. So name node will inform DN1 about that random member. The random member. What's random member now? You meant to say random node you're talking about? The DN3 is the node. Okay, so name node. Okay, node. Yes, that who is going to inform? Name node will inform DN1 about that random member. No, not really. No, there is no such kind of communication going to happen. All this decision will be done by the master. It knows, okay, someone has come up. It does healing. It does every of those. The way it treats a slave, that's exactly how it's been. So it can control and take decision on behalf of all these nodes. So if it says any failure, based on the number of nodes available, it's going to pick the data, copy it somewhere, it's going to delete the data. Every control is being done by the name node. No, so that the data loss possibility is what we wanted to completely remove. And that's why we maintain all this scenario. So if I don't maintain a replication factor, enough replication factor, yes, there can be a data failure. But in the real-time scenario, it may, by default, the replication factor is 3. But in case if your system is so critical and I can't afford to lose any of the data, we can make it as 5, we can make it as 10, any number that we need. So that depends on you. If there is a failure or a data loss, that's just because of your ignorance. Because you should have maintained, in case of it's a failure system, you should have maintained, replication factor 2 or 3 levels. If you don't maintain a replication factor, yes, there will be a data failure. Sorry, there will be a data loss, not a failure. Chance of failures removed when RF. That's too much of a code word, Tarun. I'm really not able to figure out what exactly. Chances of failures removed from DF depends on network efficiency. What exactly that means?
Shazi, it was the answer to that Manoj question.
Oh, all right. Okay. All right. Okay, let's move on and see what more we have to cover. Okay, we are pretty much okay. Let's next session's file read configuration file. Okay, this is exactly where you're going to see all those configuration file. Demo of HDFS command is what we plan for the next session. Hadoop ecosystem key components. Let me just, I have some issue running with my existing. So everyone able to install your VM? You're able to get your VM set up and start some of the commands and all those things? No commands been done till yet? Oh, so you played around with placing a file into the system and all those things? Install, okay. That's great. That's nice. Yeah, this looks like an exciting batch. The previous one, I think it was almost at the 4th session there actually. I mean, it's no placement of files, etc. Just installation. Great. I mean, that's a great stuff. What I would recommend is in case if you're not a Unix background, so just Google some Unix commands, 10 most used Unix command, and then just try to play around with your environment. Play around with as much as possible. Make directory, yeah, exactly. mkdir, dar, cd. Get used to it, that stuff. VM was huge size. Yeah, I think 4.3 GB is the size. So I have not able to come out from Grant. Okay, so you put a big command and you're not able to come out of the Grant, is it? Okay. Yeah, we'll. Yeah, quit or exit. And I think even the semicolon you may have to give for getting it. Let me show you the Cloudera environment at least for time being, so that you know what. So ACADGILD, so I need to do some more setup to run it because I was running short of my storage space, so I have to play around and change some configuration and all those things. So let me show the Cloudera part of it. No, you guys need not be doing the Cloudera is what is happening now? Why is it coming along with me? System. Did I press in some other command? Okay, fine. Yeah, nothing. I mean, this is exactly. Yeah, Vikal, maybe. So what is happening is, so I mean, previously I used to conduct some of this. So this is exactly what your environments may look like. Okay, and this comes with a huge number of other components. So my recommendation first, get used to with our environment, ACADGILD environment, and slowly when you want to move on, recommendation would be to have Cloudera VM version 5.4.2. I think 5.4.4. Sorry, that's the latest one. So that's which, but that will be very slow in performance and all those things. So don't go ahead with that time being. Once you're very familiar with what's going to happen, then only try doing that. So right now, live with the. I have installed 5.5. Okay, I mean depends on your system performance and all this. 5.4.0 was, I guess 5.4.4 is performance wise. I mean it's a humongous number of ecosystem and components switched along with that. So I would recommend not to do that. Okay, so right now, for you to get a feel of it, let me put in some commands and show you. I have tried Hive joins on ACADGILD VM, but it took close to 10 minutes time. That's fine. It's okay. So that, why is this not getting close now? Yeah, it's at times. At times it really is. Oh, I think my entire environment is stuck.
Mac also hangs?
Yeah, it does. It does when VM once in a while.
Okay.
Yeah, it's stuck now. So a quick solution would be yeah, I mean I had multiple open and I have a couple of other sessions mean, I mean, so this is a Hadoop. I have, I think, many of this stuff been open. So that could be one reason for it. Is there an Macintosh Task Manager? Oh yeah, Task Manager stuff is there. So if I close it, I can directly get this closed. Let me try that once. So this is my multiple. So I was just trying to play around with this instance just before the session. So that could have resulted into that. Normally it's not so bad. But yeah, the next session we should be able to. It's not even allowing me to shut down. So yes, I mean, since I'm sharing my screen as well and multiple other instances are running, so that could be one reason. But normally, even if it's, yeah, I think now it's. Yeah, I just wanted to make you guys have a feel of full system hang, I guess, no browser. Yeah, it's actually a system hang. So no, it's not actually a system hang. It's actually my virtual machine hang. So I have multiple instances, and I was just trying to play around with it just before. So I anticipated it, but I never thought it would have been so bad. Yeah, it's completely gone. My virtual machine is completely gone. So I may have to restart my session and do it. So which maybe. So what I really was trying to show you guys is maybe let's okay, so basically one basic step what we need to understand is client and an HDFS over here. So that's something which I wanted to make you guys have a feel of it. So I'm itching to get this things said, but it doesn't look like. Okay, anyway, only 9 more minutes left. Okay, so basically whenever you run a command, okay, let me explain that way whoever has installed it, you can just have a little bit of. So any command, if you want to hit an HDFS environment or Hadoop environment, you just need to prefix it with HDFS DFS, okay, or Hadoop DFS. Okay, great. Okay, does someone want to do that? Mac, you think you can share your screen? I've not explored much of an option, so if you want to do that, you can do that. Yeah, so that you can go ahead and. So anyone who got the turning, we can play around. I mean, at least everyone can see what's happening. So one thing which I want to tell you is, so those who are, I mean, Unix expert or not even experts, so user who have played around with the Unix environment might be knowing all this stuff, but try this ls command and HDFS, DFS, and ls. You need to unshare, is it? Okay, let me stop share. Okay, let me stop share for a quick, maybe a minute or something. In case we're not, I'll take it back. Yeah, just try that. So you don't want to give it a try. Yeah, ls is a list command, Preetham. So ls is a list command, correct. So basically what you need to, yeah, I guess, yeah, Mac is cool. So let's learn something from him. Yeah, so your Hadoop, and okay, you have an Ubuntu setup, is it? Yeah. So no, first try, just give an ls command, Mac. Yeah, use system. Okay, so that's fine. So now what Mac has given is Hadoop DFS minus ls command, right? And now just just give plain ls command. So see, someone would have been expert in this area, but someone who does not is what I want to just do an ls, just do an ls command and enter. It might be a huge file system, right? Yeah. So see the number of files. So this exact, okay, if you, all right. So this exact difference is what I want to. So whenever you are making an LS and you can see the number of files over here, this is typically what we call as the client. Okay, but you might have seen from the previous diagram, client interacting with an HDFS environment and stuff like that. So this is nothing but the one which is showing the client. And when I hit the Hadoop environment, that is Hadoop DFS minus LS. When he run that command, I think okay. Once again, if you can you do that Hadoop DFS, Hadoop DFS and LS command? Yeah, just enter. Yeah. So this is nothing but the Hadoop environment. The first one is the client environment, and the next one is the Hadoop environment. So you can do one thing. Do you have any file or something available over here? In this current any files which you want, okay, I think employee.java, that's fine. You come to the terminal, no issues. Come to the terminal. I just saw an employee.java over there. So why don't we take that employee.java and put it in our some environment which you think you have full access to, which environment /temp, right? Okay, so shall we place that into the /temp environment? So HDFS DFS. So just put HDFS or maybe Hadoop DFS. So both works, or whichever you're familiar with. HDFS DFS minus put command, and I think you have what employee.java, right? Yeah, employee.java. Is there an emp.java? I'm not sure, because I can see an employee.java there. Is the emp.java file exist in that location? How much time we have? It's left for us. Yeah, we have exact 4 minutes, so no issues. Okay, yeah, let's do it over there. Now, before doing that command, just run a ls command, no, so that we know what are the files sitting over there. Okay, on the desktop, just put an ls. Okay, so this many files you have, great. So HDFS. So first and the foremost thing, what you need to understand is, anytime you want to enter to hit the Hadoop environment, you need to prefix it with Hadoop command, or Hadoop command is nothing but HDFS or Hadoop. So HDFS DFS. Yeah. Now let's go ahead and put your one readme.txt to the Hadoop environment. HDFS. Okay. Hadoop DFS space minus put. You don't need to give the entire stuff, because you are sitting in that. You can just give readme.txt. I mean, just for the simplicity just give the readme.txt. It should be case sensitive, I believe, because yeah, Unix readme.txt slash, I can't see a terminal now. Okay, /temp. Yeah, if temp is existing, yeah, just enter. So let's see that file in the temp directory now. Yeah, now HDFS DFS minus put, and then let's go into the Hadoop DFS minus ls and space temp. Yeah, so let's enter it, and you should be able to see the readme. The first file is the readme. So that's as simple as that. This is how, from the client, you have actually moved a file from the client to the Hadoop environment. That's exactly what has been done. And can you see the first line? It says the privilege of user group and all those things, right? Just after that, you can see a 1 over there, right? Just after that, you can see a 1, and that's exactly the replication factor. Okay, that's the replication factor. So only 1 by default, you're given a replication factor of 1 for your file. That's what it says. So that's why you have there is a way of giving it. I forgot that all those commands. Rep set rep, I believe, minus set rep, and you can change it minus set rep. HDFS DFS minus set rep, and you can just give it as 3 or automatically you are overriding those parameter which will be available in your configuration file. Temp is the Not really, Vikas. So what is happening is whatever command we have prefixed with HDFS, DFS is how we are interacting with the Hadoop environment. Okay, I mean that's some concept which I will be explaining a little in detail, because I mean by this the only intention was So this is exactly the entire Hadoop root directory what he's showing now inside the temp. This is a GUI version of it where you can see all those environments. So inside the temp folder, I can see all these files. Can you go to the root folder once again? Just remove that TMP and then put a go. Just root. Sorry, where do you reach? So come to that 50075. And then enter. Browse the file system. So this, that's it. So this is exactly in the root. The / command means the root of this is the Hadoop systems root. So inside Hadoop system, you have multiple directory creators. So these are all the directories sitting inside your Hadoop system. So we are going to explore and find more about it in the next session. So that's all. I mean, thanks, Mac. That was a real help from your end. So just to get a feel of what exactly Hadoop looks like. We are going to explore most of this. So from the next class onwards, you're going to see more of how exactly to play around with the environment.